All right, this is the first screencast for chapters 16 and 17, which are on energy resources and their efficiency. One of the things we just kind of like have as something we accept is oil. We've had it for a very long time throughout the Industrial Revolution, or at least in the last 100 years or so. And we just expect it's always going to be there. But we do now know it's just not going to last forever. These numbers on here, you can see like if we were just to focus on their oil, how long it would last. And you can kind of see that all of them relatively are not that long. So we see that it is a limited resource. This little picture here shows an oil platform. We don't, of course, see these at all here in Michigan, but they're usually going to be found somewhere. Something like this is offshore. And we use these to, when we have a known location where there's a lot of oil, we set one of these things up, and it can be there for a very long period of time, tens of years. And they're very expensive, and they're huge. This one here, I believe the cost was $12 billion. And then, of course, you can factor that into, well, that must be a lot of oil to make that kind of investment. So then you have to ask yourself, okay, with all the environmental factors that go along with whether it's the oil, the CO2, could that money be spent differently? And these are just options. As far as our energy goes, almost all of our energy originates from the sun. So this goes to that idea from the very beginning of the course. How does nature do things? So as far as energy goes, nature relies almost 100% on solar energy. And if we're looking for sustainability, this is a route that we should be looking as well. You can see generally how we do things. About 80% of our commercial energy comes from something other. Ultimately, it probably originated with solar energy, but we tend to focus on these non-renewable fossil fuels for our energy usage. This little graphic here is looking at our production, and this is for the United States. In the last 70 some odd years, the energy that we have produced, and you can see right around 80% or so is from fossil fuels, coal, natural gas, oil, those three. And then just the remaining 20% is the renewables. And you can see how it's kind of changed over time. One of the big things you'll probably notice in there is the change in coal, especially on the graphic on the right-hand side. If we will take a look, I don't know if my mouse will show up here. Let's go to here. This could be difficult. We'll see. If we take a look at the natural gas, we can see how that has changed quite a bit over the last so many odd years, going from maybe 2000 or so. You can see that this has changed quite a bit. And then, of course, oil has gone up quite a bit as well. The one that's gone down, the only one that's really gone down, is coal. You can see how that has markedly gone down. So natural gas's gain has been coal's loss. Let's see if I can get this to punch forward. There we go. And then this is our consumption, looking at as far as what we use. And I won't use the cursor just to keep things moving along. But again, you can see how natural gas consumption has very much taken off, and coal has gone down. And even with all of the focus and the production of renewables, relatively speaking, it's still kind of low. It is moving in a positive direction, but it's quite a bit lower. I guess maybe one of the big takeaways we look at this is our energy usage is still increasing, and we need all these other ones, whether it's renewables or nuclear even, to offset some of those others. But we do use quite a bit more energy than we ever have. And you can just look at petroleum and natural gas. They are both in a very positive direction. This little schematic just kind of gives us an idea of, if all of these geological or energy uses, we were looking at them geologically and how we actually get them. In the previous chapter, we're looking at the strip mining, getting coal, so you can kind of see that on the right-hand side, as far as that being like a strip mining. On the left-hand side, and I will kind of grab this one here, looking as far as this area over here is like a fracking. And you can see how the wells will go in to a formation. And on the top, you're going to find that you do sit the natural gas. That typically is going to float on top because it's less dense before you get to the oil. But all these other ones you can kind of see in here as well, as far as whether it's geothermal or offshore drilling too. This slide here is looking at the energy profile usage that various countries use. And you can see all the ones listed there, whether it's coal or oil or nuclear, hydro. A couple are interesting on here. You can see how China has its split mix in there. You can see how much coal they use comparatively, even though they do provide an incredible amount of investment in some of those renewables. It's just not that much in comparison to the others. The United States is moving in a positive direction. You can see that as far as our natural gas, it's now 35% in comparison to oil, which is 38%. And again, this is all the energy consumption. The one I find most interesting is if you look at France. France, 37% of their energy consumption comes from nuclear. So no one else really comes that close. Sweden a little bit. But they very much still heavily rely on their their nuclear energy profile. I thought that was kind of interesting. Looking at this slide, we're just kind of focusing on the idea of the net energy. So it's the return on investment that you get for it. And they divide it into 3 different sections, whether it's just for your home heating, industrial usage, and then for transportation, because we use different things for different applications. Space heating, you can see this passive solar, which is quite interesting. That just means like having your house available to let sunlight in. And that's not something we typically think a lot about. But if you have south-facing windows in the wintertime, you definitely want those shades pulled up to take advantage of that free energy from the sun. And then just looking at the other ones on there, I won't spend a whole lot of time. You can pause it and take a look. Just seeing how these energies relate to each other. The energy you get based on how much energy you have to put out to obtain it. So commercial energy uses are those that you have to buy. And we use them for all our everyday applications. Subsistence energy is just, of course, people just living their lives from day to day, and typically that's going to be like a biomass type material, and this is going to be again more likely in developing countries. This is a video which we won't actually watch here. Maybe we'll talk about in class, but most likely not. This is just kind of getting into the idea of definitions. Crude oil is a mixture. So a lot of times we may think that oil is the stuff we put in our cars. We pump it out of the ground, we put it in our cars. It actually requires a lot of refining to get the stuff we want out of it. So it's a mixture of a variety of things. In the next slide over here, and I think is going to show you kind of a profile of all the things that are within there. The big thing we want out of oil is gasoline. And there's some applications we can put out to obtain specifically the gasoline. But there's a lot of other things that come out of oil as well. This is called the refractory tower. And you can separate all the components of crude oil based on their boiling points. So things that have a really long carbon chain. Things like greases and asphalts, those are very, very dense, heavy, long carbon chains. And those, no matter how much you heat them, you're not going to get them to boil, and they're going to be found near the bottom of the refractory tower. Things that have shorter carbon chains and are less dense, they will boil at a much higher temperature, and they are going to find themselves towards the highest point of these refractory towers. We have one of these, I believe, in Detroit. It's called the Marathon Refinery, but the majority of these, are found in the South, like Texas. Of course, that's where they get a lot of oil. All right, this is going to be a good place for me to pause, and then we'll take on the second lecture after this one.